So now that we have vectors, I think it's time to get our spaceship moving, or a triangle, whatever you want to call it. I'm going to call it a spaceship from here on out. I want to get that thing moving on the screen, do something a little interesting. So I'm going to go to Solution Explorer. Let's pin this for now. I hit Control-Alt-L to bring that up. I think Control-WS is the same thing, but I'm not sure. I'm going to right-click on Sandbox Game, set this as our startup project instead of the testing project that we were working with in the previous videos. Control F5, let's just make sure we still get our triangle. Now, you may notice this triangle's a little, it's not perfect. In fact, if we go over to my GL window and we put in these perfect numbers, but then what actually shows up on the screen is a imperfect triangle. You might think our triangle, well, yeah. I'm going to address that issue in a different video. You see here the triangle's not even centering on the window as I resize it. And that has to do with viewports and things like that. But let's, for now, I just want to get this triangle moving. Let me bring that back up. Now, if you remember from the previous video, we had these OpenGL coordinates where the origin is right in the middle of the screen. I'm going to try to approximate this as best I can. Freehanding. Oh, that's terrible. Freehanding my coordinate system. I don't think my tool allows me to just drag lines. Otherwise, I'd drag a line. And this is probably the best we're going to get. Okay, so the origin of our window is right here. Right? This is positive y. This is 1 here, 1, positive y, negative 1, and the y right there, so that's negative y. Positive x over here, positive 1, and negative 1 in the x. Okay? Now I want to take this triangle here, and let's move it roughly 0.5 here, 0.5 there. And again, you may think, Jamie, this distance from here to here is much longer than this and this. How is this 0.5 versus how is this 0.5? And that has to do with how OpenGL does our screen and stuff. Again, I'll talk about that. For now, in this, I'll talk about that later. In this video, I'm just going to say it is 0.5. It is 0.5. Let's deal with it. I want to draw my triangle right here, or my spaceship right here. So we'd end up with something maybe a little bit lower there. Something similar to this. Okay, notice the origin of the triangle's in the middle, but I can get a thicker pen. Let's do thick. Alright, there's our spaceship. I want to move it there. And the origin of our spaceship, it's right here now. I want to move it right here. Alright, so think about what we have set up here. Let's try, I'm going to try green. This vertex, green thin, please. This vertex, where's that vertex located? If you remember, we go back here and we put that first vertex at 0, 0, 0.1. Alright, so 0, 0, and then 0.1. Then this next vertex is negative 0.1, negative 0.1. So negative 0.1, negative 0.1. Alright, and then this vertex is 0.1, 0.1. And you can think of them as positions, which is okay. But now that we've learned a little thing about vectors, we can think of them now as actually vectors. So if I draw the actual vectors representing these vertices, there's our first one, our second one, and our third one. And to move this white spaceship over here, essentially what I got to do is take this point here and move it right here. Okay, that top vertex is going to become this vertex. This bottom left-hand vertex is going to become this vertex. And this left-hand vertex becomes this vertex. Well, this is where linear algebra starts to get beautiful. We know about vectors. We have a vector representing this position. You remember I said that we're going to go 0.5, 0.5. 0.5 in the x, 0.5 in the y. Well, that is a vector. Let me pick, I don't know, should we do yellow? Yellow doesn't show up sometimes, but we'll do yellow. Yellow. Yeah, it looks poor on the white, but on the black it's fine. That's our positional vector. 0.5, 0.5, and syntactically, as far as the math goes, here's the angle brackets. Well, in order to move this vector, this blue vector, over to here, or this tip of the blue vector over to here, it's really easy. If I take this yellow positional vector that I just drew here and I draw it and I just move it, if I could pick it up with my hand and move it right here, then we'd get something roughly like that. And all of a sudden I hope that you see, oh, vector addition. This vector plus this vector results in, if I can draw it, oh, come on, this vector, and it's still a vector. Okay, if you remember from the vector addition tool, let me bring that back up real quick. Let me drag this over here, clear this off the screen for now. Here we go again. It's so our original vector, well, I don't have it now, but we have, if I can adjust this right, we have the tip of our spaceship right here, and then I'm trying to move it over. Here we're on a scale of 10 instead of a scale of 1, so I'm going to go over 5. This second vector, let's say this is our positional vector, this blue vector here. I'm going to bump this up to 5, and bump this one up to 5. So this vector, this little vector, our first vertex vector, if you would, plus our positional vector moves, it gives us a resulting vector of this red vector right here. Okay, A plus B equals C. And so the top of our spaceship will go right here, which is roughly what we want on this scale. We want our center of our spaceship at 0.5, and this scale is 5, 5. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's the origin of our spaceship, so the top of the spaceship would be right there. That's what I'm trying to accomplish here with these vectors. Now the same is true for all these vectors. This vector is going backwards. If I took our positional vector here and tagged it on the end of that, we'd end up down here. We'd have a resulting vector right here. And same with this. This vector plus our positional vector will bring us out here. So let's use vectors, see if we can move the ship. We wrote our vectors, right? Don't we have a vector class we can use now? So let's do that. I have to change up a few things though to make this work. First of all, I called these verts and I did floats there because we didn't have vectors, but now I want to think of them as vectors. So I'm going to go here and I'm going to say vector 2D, I believe is what we called it. But we get the red squiggly, we have to do the pound include. So I'm gonna move this GL window include right there, and then put this one here. The reason I put this GL window include right here is because it's the header file for the CPP file, and generally I put them as the first thing in there. But glue requires, remember from previous video, glue requires it's the first include, so I have to include that above the GL window. I want to pound include my, if you remember, it's math/vector 2D. You see my IntelliSense while I hit Control Space. IntelliSense is not coming up. Can you think why? I'd pause the video and think about why. The reason is we don't have our include set up for this project. We did it in the previous video. We set up the include path for this, but we didn't do it for this one. So I'm going to go to Properties here, C++, General. Actually, was it there? No. Okay, General, Additional Include Directories. Let's use the editor here. It's going to be the project directory, but let's go up one and into engine, and that's where you'll find my engine include. So now I can say math instead of math/vector2dh. Okay, so now I still got the red squigglies because I haven't exposed the namespace here. So in this compilation unit, I'm going to say using, I think it was math, was it? :vector2d. Okay, again, let me just right-click here, open the document. Remember, we put a namespace on here. All right, so now I'm saying vector2d verts. Now I can build this, and it should. Well, it might build. Let's see. Build started. Build succeeded. And so you may think, we weren't. How do these get converted to vectors? Okay, well, something I didn't show you in the vector2d file over here is, hopefully, if you're not familiar with conversion operators, don't worry about this, but if you want to learn about them, go watch my C++ list. But essentially, the compiler sees the 0 and says, oh, is there a way I can convert a 0 to a vector? And it realizes, hey, these parameters are defaulted here, so I could pass 0 here for one of the parameters for vector2d, and I'm going to I'll leave it as an exercise to you to figure out which one it's going to happen to, if it's going to pass it for x or for y. But then it also does the same thing here So these you can think of this constructor here as a conversion operator. The compiler views it as, hey, I can convert a float to a vector. I'll just pass it to this constructor for either the y or the x. I'll leave it as an exercise to you to figure out. I don't want, and I should have mentioned this when we created the vector class, but I like to wait until we have a need to drive this. I don't want the compiler automatically converting random floats to vectors without me knowing about it. Okay, I want to allow that functionality, but I want to force a cast to make that happen. So I'm going to come here and drop the explicit keyword here, which will prevent that automatic conversion from happening. Control-Shift-B, build. You'll see that we finally error out. It's saying, you want me to convert a float to a vector? I can't do that. Okay, and so the explicit means, hey, if we're going to convert a float to a vector, they got to do it explicitly. And so let's do that. I want to convert two floats together into a vector. I just don't want to take one float. All right, so vector 2D. Actually, let me use a trick here. Alt drag vector 2D. Call the constructor, and then I'm gonna go alt drag parenthesis. Okay, so now, yeah, as far as RAM's concerned, there's still two floats next to each other in RAM. A vector 2D isn't much more than just two floats next to each other. But now I can think of them now as vectors instead of just two floats together. Okay, how's that going to change the rest of this? Let's look here. I know I didn't explain this code in too much depth. That's because I'm waiting for the graphics section of our engine to really get into what these are doing. But I can tell you on a high level, we're saying, hey, OpenGL, make some RAM. Oops, don't delete it. Make some RAM on the graphics card for me, and stuff this in that RAM. Actually, let me reword that a little bit. Make a buffer, then make some RAM associated with that buffer. And by the way, while you're making that RAM or allocating that RAM, put this stuff in it. I'm going to change this up a little bit. I'm going to say GL dynamic draw. Right? And again, don't worry too much about it, but basically that means, hey, OpenGL, I'm going to change this data a lot, so it's going to be dynamic. Don't optimize it, or put it in some place where you can do some optimization. This is purely a hint. We'll get to that later. And then I'm going to pass null here. Nope, I want null. Alright, so I'm saying, hey, give me that much RAM still, but I'm going to tell you what I want that RAM to be later. And the place to tell it what that RAM's going to be is down here in the paint. Alright, in the paint function, think about what we have to do. I'm going to bring, I need to bring that window back up. Can I do this? And then can I do this? Oh, is there a way to make the background black? Probably not. I need to take our original vertex here and add our position vertex. We don't have a position vertex yet, so let's do that. Oh, there's another diagram we were working on. Let's make a position vertex. So I'm going to say somewhere in here, we'll do it right here. Vector 2D ship position. How about that? Ship position. And I said I want to put that at 5 or 0.5. That's going to be our ship position. And then, oh, I don't want to do this in the initialized GL. I'm going to cut this line. I want to go to the paint. The paint GL. Leave this stuff in there. That's important. Right here, before we do our drawing, I'm going to insert our ship position here. And what I have to do one by one is for each one of our vectors in our ship, which there's 3 of them, I have to take it and add our position vector to it. Okay, I hope that makes sense. Take our ship vertex and add our ship position vertex. And I have to do that one by one. So let's see if we can do that in a loop or something a little more intelligent here. First of all, I need to know how many vertices there are. There's 3. I could do that as a magic number, but I'm going to try to be a little bit better than that. I'm going to say static const unsigned int num verts gets size of verts, which will take the size of this entire array in bytes. There are 1, 2, 3, 4, 5, 6 floats in this array. Floats on my machine are 4 bytes each, so 6 times 4 makes 24, so size of verts is going to return 24. I'm going to divide that by the size of the first vert, star verts here. This is a typical C++ programming trick, but size of star verts is going to give me the size of the first element in the array. The size of one vector is the size of 2 floats, so that would make 8. So 24 divided by 8 is 3. Number of verts will be 3. The reason I went to all this effort is if I come back and modify this, then I don't need to remember to do this. And chances are I won't remember to modify the magic number out here, and then I'd have a bug in my code. Okay, so ship position. So let's make a vector 2D translated verts. I'm going to make that an array of num verts. I'll put this directly on the stack. And then I'm going to say for int, maybe unsigned int, let's be consistent, I, int I get 0, I less than num verts, I plus plus. And then in here, what I want to do, like I described with this drawing up, is I'm going to take the original vert, add the positional vert, and store that as my translated vert, this green vert, or this green vector, if you would, right there. So let's do that. Translated vert sub I gets vert sub I plus position, or did I call it ship position. Okay, so the regular vertex position plus the ship position will give me the resulting translated vert. Notice I'm not modifying these verts, and you'll get used to this. We take the original verts, we do some work on them, but then we assign the result back to somewhere else. Now I'm going to send this result back down to OpenGL and say, hey, draw that one instead. So the function to do that is gl sub buffer data, or buffer sub data, and gl array buffer. Again, don't worry too much about these arguments, just go with them as I do, and we'll get to them in the graphics videos. Offset, start at 0 in your buffer. The size is size of, I could take the size of translated verts, or the size of verts is going to be the same thing here. So size of translated verts, and then translated verts. Okay, so I think that might be good. Let's then after we do that, we send that down to the graphics card. We say, hey, go draw it. So drum roll. Hopefully our ship moves on the screen. Okay, Control F5. And we get our triangle moved. How cool is that? Okay, well, this video is much too long. But we use some simple vectors to move our spaceship on the machine on the screen. We're going to use vectors and matrices, but vectors a lot from here on out. In the next video, I'm actually going to get this spaceship to move with our frames so we can get something more interesting than, hey, pop, pop, the triangles over here now.